Hello, and welcome to the Business Analytics with Excel course offered by Simplilearn. In this lesson, Analytics with Excel, we will study how Excel helps us in improving our ability to collect, analyze, and forecast financial and business data to produce valuable insights and representations. Let's say we need to calculate a missing value from the given data. We have decided to solve it on our own and tried hard by plugging in different numbers till we found the correct answer. This consumed a lot of time and effort. We might find it incredible if we say that we can perform this task in a minute. With the help of the What If Analysis feature of Excel, it's easy to experiment with our data in no time. With the help of this feature, it's possible to experiment even with incomplete data. In Excel, there are various What If Analysis tools available, such as GoalSeek, Scenario Manager, Data Tables, and Solver. Well, let us take a look at a scenario to understand the use of these tools in detail. Suppose we want to buy a house through a home loan facility offered by a bank. We need to calculate the terms of the loan. With the help of What If Analysis tools, we can calculate it easily. The GoalSeek helps us to evaluate the payment formula and return new values for rate, term, and the principal to fit our desired payment. With GoalSeek, we can even work backwards, that is, starting with the result. With the help of Scenario Manager, we can substitute input values for multiple cells, allowing us to view the results of different input values at the same time. Data tables allow us to do a comparative analysis of available data. It also allows us to view the results in the table without changing the original formula references. With the Solver What If Analysis tool, we can find an optimal solution for a formula in one cell by adjusting the values in other cells according to our specifications and constraints. Before going into details, let us start this lesson by defining the objectives of the lesson. After completing this lesson, we will be able to explain histograms and how to create them in Excel, list the steps involved in solving the linear problems using Solver add-in, describe GoalSeek to get the desired result, list the steps involved in comparing and creating different scenarios using Scenario Manager, and analyze results for different input values using data tables. Before experimenting with our data, we need to represent the data graphically to understand them. This is done with the help of histogram. Let us start this lesson by defining histogram. Histogram is a graphical representation of the distribution of a single variable. The next question that comes to mind is, why should we care about distribution? The statistical methods needs to determine whether our data is normal or bell-shaped. A histogram is used to quickly check if the data is normal or not. Consider the example shown on the screen. This is the dataset that keeps track of resolved calls answered by each employee with respect to the call duration in a BPO organization. A class interval is the size of each class into which a range of variables are divided. For example, in our dataset, we want to check the number of calls answered in a given time interval. So for this histogram, the minutes bucket will be the class interval. Let us now understand how to create histograms in Excel. To create a histogram in Excel, we have to first install the Analysis Tool Pack in Excel. Let us understand how to install the Analysis Tool Pack. Click on the File menu and choose Options. In the navigation pane, click Add-ins. Select Analysis Tool Pack from the Inactive Application Add-ins and then click Go. In the Add-ins reference box, click Analysis Tool Pack checkbox available under Add-ins and then click OK. Before creating a histogram, we have to define bins. In our current data set, we want to analyze how many number of calls were answered in 0 to 3 minutes, 4 to 7 minutes, 8 to 11 minutes, 12 to 15 minutes, and greater than 15 minutes. So let's insert these class intervals into column G. After defining bins, we must insert maximum value of the bin range in column H. This column will help Analysis Toolpak to create a histogram. Let us now understand the steps to create a histogram from a given data set. Click Data tab. It's under Analysis Group at the right corner of the screen. Click Data Analysis. A Data Analysis dialog box will appear. In the Data Analysis dialog box, select option Histogram and click OK. A histogram dialog box will appear. In the histogram dialog box, pass input range, bin range, and output range. In the input reference box, select the range D1 to D40. In the bin range reference box, select H1 to H5. Click Labels checkbox, as we have a header in our data. Under the Output section, we can select whether to create a histogram in a new worksheet or in the active worksheet. Click the Output Range option button. Click in the Output Range box and select cell J1. We can design a histogram chart with 3 different options, namely a Pareto chart, a cumulative percentage, and a chart output. A Pareto chart is a special histogram with the columns sorted from the tallest to the smallest. A cumulative percentage shows cumulative percentage line graph in addition to the bin's total. A chart output shows an embedded histogram. In our current example, we will select cumulative percentage and chart output checkbox. Click OK. Excel now generates a frequency table and a histogram chart at range J1. We can also adjust the position of the chart by dragging them to the desired place. We can also change the size by clicking and dragging on the outer edge of the chart. We can also edit the frequency table so that the horizontal axis makes more sense in the histogram chart. To do this, copy bin column and paste it as a value in the frequency table. From the given histogram, you can easily analyze that most of the calls are answered in under 15 minutes, although there are a significant number that require 15 minutes or more. Now that we have understood how to create histograms in Excel, let's move on to the next topic, Solver add-in in Excel. In Excel, Solver add-in is used to solve complex linear and nonlinear problems. To use Solver add-in, we first need to load it into Excel. To enable Solver add-in in Excel 2016, click on the File menu and choose Options. Now, select Add-ins from the left side in the Excel Options dialog box. Select Solver add-in and then click the Go button. In the Add-ins dialog box, click the Solver add-in checkbox and then click OK. Once we have enabled the Solver add-in, we can find the Solver command in the Analysis group on the Data tab. Well, look at this scenario. An organization is preparing a trip for 400 employees to Vegas. It was decided to go by bus. The admin team has contacted an agency which has 10 buses of capacity 50 seaters each and 8 buses of capacity 40 seaters. However, only 9 drivers are available in a shift. The rental cost for a large bus is $800 and the small bus is $600. The admin team has to calculate how many buses of each type should be used at the least possible cost. These kind of complex linear problems can be solved using Solver add-in. In this problem, we have number of buses as variables and number of employees and number of drivers as constraints. These will act as our basis to formulate an optimal solution and calculate the least possible cost. In cell F13, we have used the formula to calculate cost, multiplying each bus seater cost with the number of buses. Now let's calculate the minimum cost using the following steps. Click on the Data tab and select the option Solver Add-in. A Solver Parameters dialog box will appear. In the Set Objective box, we will enter the name for the objective cell or the cell reference. Here we will select cell F13, which reflects the cost. There are three options available under Set Objective box, namely Max, Min, and Value of. Click on Max option if we require the value of the objective cell to be as large as possible. Click on Min option if we require the value of the objective cell to be as small as possible. Else, click on Value of if we want the objective cell to be a certain value, and then type the value in the box. For our problem, we can select the Min radio button, as we are required to calculate the minimum cost. In the By Changing Variable Cells box, type the name or reference of each decision variable cell. We can select cell C11 for 50-seater buses and D11 for 40-seater buses. In the Subject to Constraints box, enter any constraint that we want to apply. To add a constraint, click Add button, and an Add Constraint dialog box appears. Enter all four constraints. Number of employees equals 400. Number of drivers less than or equal to 9. Number of 50-seater buses less than or equal to 10. And number of 40-seater buses less than or equal to 80. Select the Make Unconstrained Variables Non-Negative checkbox, as we want the result to be positive variable numbers. Click Solve, and in the Solver Results dialog box, read the message at the top and bottom of this dialog box. After reading this message, do one of the following. Click on Keep Solver Solution if we wish to keep the final values in the decision variable cells. Click on Restore Original Values if we want to restore the values of the decision variable cells at the time we clicked Solve. If we want to modify the solver model, or resolve as our next step, then select the Return to Solver Parameters dialog checkbox. Here, we will enable Keep Solver Solution. Finally, click on OK. Note that the solver has returned the result of 6,200 in the F13 cost cell, which is the least possible cost for the trip. In this way, we can use Solver Add-in to solve linear problems. In Excel, a number of powerful tools are available to perform complex mathematical calculations. What-if analysis is one of these tools. What-if analysis is the process of changing the values in cells to see how those changes will affect the outcome of formulas on the worksheet. This feature can help us experiment and answer questions with our data, even when the data is incomplete. There are three kinds of what-if analysis tools that come with Excel, namely Scenario Manager, GoalSeek, and Data Tables. Let's start with the first what-if analysis tool, GoalSeek. Whenever we create a formula or function in Excel, we put various parts together to calculate the result. However, the GoalSeek works in the opposite way. It allows us to start with the result, and it calculates the input value that will give us that result. Let us understand this with the help of an example. Suppose our business has a profit of $20,000. Now we've set ourselves a new profit goal of $25,000. Currently, we are selling 5,000 items at $10 each. Assume that we will still sell 5,000 items. We are required to calculate by how much we should raise our prices in order to reach the new profit goal of $25,000. Here, in the sales figure table, we have sales price per unit as $10. Let's see how GoalSeek helps us calculate prices to meet our new required goal. From the Excel menu bar, click Data tab. Under Forecast panel, select What If Analysis button. Select GoalSeek from the list. A dialog box will appear with three fields, namely Set Cell, To Value, and by changing cell. Set Cell. This cell contains the desired result. So in the Set Cell reference box, enter C17, Net Profit Cell. To Value. This is the required result, or the new what-if amount. In our example, it is $25,000, as the new profit we want to set is $25,000. By changing cell, this cell reflects the answer produced by GoalSeek. Here, we'll set cell C12, the selling price per unit. Click OK button. Dialog box appears. This will show whether GoalSeek was able to find a solution or not. Click on OK button to accept the solution. The result appears in the specified cell. In our example, GoalSeek calculated that the new selling price should be $11 per unit in order to meet the new profit of $25,000. Let us now move to the second what-if analysis tool, Scenario Manager. It's a built-in tool that allows users to change 32 variables simultaneously. With the help of Scenario Manager, we can create scenarios with different sets of values and switch between them. Consider the example. The XYZ Limited Company sells products through two marketing techniques, namely telemarketing and direct marketing. The company wants to predict the total profit in a situation where the selling price per unit and the number of product may be different. In order to compare profits for different input values, the company has identified two scenarios, namely best case scenario and worst case scenario. As expected, in the best case scenario, the company includes products that have a higher selling price sold to a maximum number of customers. And in the worst case scenario, the company includes products that have the lowest selling price sold to a minimum number of customers. Consider the given sales table. Here, we want to change cell C7 and C8 values based on our worst case and best case scenario. In worst case, the number of units sold is 4,000, cell C7, and the selling price per unit is 9, cell C8. In best case, the number of units sold is 5,000, cell C7, and the selling price per unit is 11, cell C8. Now let us use Scenario Manager to create these scenarios. Click the Data tab. Under the Forecast panel, select What If Analysis. Choose Scenario Manager from the What If Analysis option. The Scenario Manager dialog box appears. Click on Add button to add a new scenario. In Scenario Name reference box, add the first scenario name as worst case. For changing cells, select the cell title, number of units sold, and the selling price per unit range in our model, cells B6, C7, and C8, and click OK. In the Scenario Value dialog box, assign value to B6 as worst case, C7 as 4,000, and C8 as 9. Now, to add another scenario, click the Add button again. Repeat the same steps and add values for best case scenario. Enter scenario name as best case. For changing cells, select the cells B6, C7, and C8. Assign value best case scenario in cell B6, 5,000 to C7 and 11 to C8. Now let us see the results of best and worst case scenarios. In order to visualize the result of a scenario, select the corresponding scenario and click the Show button. If we select the worst case scenario, Excel will reflect the worst case results. If we select best case scenario and click the Show button, Excel will show the best case results in our model. In this way, we can analyze different scenarios with different sets of values and switch between them. Scenario Manager helps to create a scenario summary sheet. With the help of this sheet, we can easily compare results of different scenarios. To create a summary sheet, first select the Summary button in Scenario Manager. Next, for the results cell, select cell C13, Net Profit cell, and click OK. Excel creates two types of summary tables, namely Pivot Table and Normal Table. We can select required output using the Radio button and click OK. In the summary sheet, we can see best case, worst case scenarios with changing and result cell values. Now that we're familiar with two what-if analysis tools, GoalSeek and Scenario Manager, let us understand the last what-if analysis tool, data tables. Data tables take sets of input values and determine possible results. Instead of creating two different scenarios in Excel, we can quickly try out different values for formulas by creating a data table. Let us consider an example to illustrate their use. Rod is a sales manager of XYZ company, and he wants to determine that if he sells products at two different selling prices to two different customers, then how much profit will he make? Now let's solve the problem with the help of data tables. In the given table, E10 to J15, cells F10 to J10 shows the number of units sold, and cells E11 to E15 depicts the selling price. To create data table in Excel, first, insert the profit formula in the first cell of our table. Now, select Output Table. Click the Data tab. Under Forecast panel, select What If Analysis. In the Data Tools group, choose Data Table from the What If Analysis option. Data Table dialog box will appear. In the resulting dialog box, fill the row input and column input. In our table, we have the number of units sold in row, so select range C11 in the row input. And selling price per unit is in the columns, so select range C12 in the column input. Now click OK. Data table will generate profit on the basis of the number of units and selling price per unit in the output table. In addition to this, Excel also provides a data analysis tool called Descriptive Statistics, which produces a summary of the key statistics for a data set. Excel provides a great feature to quickly provide statistical data like sample variance, mean, and standard deviation for our data set in just a few clicks. Consider the given table. Here, we have the score obtained by two students, and we want to determine the statistics regarding them, like what is the standard deviation and what is the mean of the score. To produce descriptive statistics for the given sample, we should execute the given steps. Under the Data tab, click Data Analysis. Select the option Descriptive Statistics in the Data Analysis dialog box and click OK. In the Input Range reference box, select Student A scores. Select Group by Column. If we want to include the heading, check the labels in the first row. In Output Reference box, select the output range and select the cell F4. At last, click the Summary Statistics checkbox and click the OK button. Excel will generate a summary table for Student A. Similarly, we can create the table for Student B. These results help us to find out statistical data for two samples. Now that we know how to create histograms, let us do a small exercise to reinforce the concepts learned. We will provide you a step-by-step assistance to implement the what-if analysis and produce descriptive statistics. Let's start working on this together. You are the director of a company selling iPhones to the global market. You've decided to expand your business and therefore started analyzing the age group of your maximum buyers You want to understand what you can add to your product, how to advertise it, and where to advertise it. You also plan to quickly check some statistical data. Consider the given data set. The data set is keeping track of the product sold information by order ID, customer information, and date. To have a better understanding of your data set, you can represent the data graphically, so you can generate a histogram for the data set. Now that we've learned how to perform analytics in Excel, let's have a look at the key points of this lesson. A histogram is a graphical representation of the distribution of a single variable. Solver what-if analysis tool finds an optimal solution for a formula. GoalSeek lets us start with the desired result and calculates the input value that will give us that result. Scenario Manager helps us in viewing the results of different input values at the same time. Data tables allow us to do a comparative analysis of the available data. And Descriptive Statistics produces a summary of the key statistics for a data set. This concludes the lesson, Analytics with Excel. In the next lesson, we will introduce you to data analysis using statistics. Hello, and welcome to the lesson Data Analysis Using Statistics.